All right, so I've loaded up SolidWorks. I think I mentioned, well, in one of the classes, or maybe last time, that when the new software comes out, in this case 2019, it's the end of January. We ought to be seeing Service Pack 2 here before too long. Each of the solid modelers handles updates and service packs in their own way. So SolidWorks typically has 5 service packs throughout the year, and by the time you get to Service Pack 5, they are pretty well into the next beta testing and pre-release and release of the next year's version of the software. So the versions do not change drastically. Maybe they learned their lesson from 2007 to 2008 when they made the big jump to this format. I was a little upset in 2003 when they went from 2003 to 2004, and it was a fundamental change. And then by 2007, no big deal. 6 months, we won't think anything of it. All right, so a couple of things changed in 2019. I say all of that because I want you to realize that if you're looking at 2018, I've discovered a few things that are not entirely lined up as far as some of the visual clues. All right, so I'll try to point those out as I see them. So I'm creating a new file, and what I'm going to do is kind of that manufacturing stack up. All right, so first I want to look at, we mentioned some of the drawing templates, and so I've created a few. And so going into just a blank template with a couple of zones, that's handy for a non-controlled document. I can put in notes, I can type anything in, I can get a pretty picture, I could do an exploded view, but it doesn't have to have all the formality of the full template. So blank sheets and reasonably good starter templates are kind of a good way to go. I'll do another one here. All right, so let's save the drawing for last. All right, so I want to mention real quick too, since I got ahead of myself, that if you are looking at the novice screen, these are all of the SolidWorks defaults. You want to switch over to advanced, and then you should have part, let's see, assembly, and drawing. I've created the rest of these to perform specific functions for either the design or to have something built in so I'm not having to change it. So my part, inch, and fractional inch served a purpose. The standard inch, metric, those I can pick. Most of the time I'm in such a habit of picking inch that I will pick inch even though I'm going into a metric part, and then I have to change the units over to metric anyway. All right, and then our assembly inch or just default assemblies, and then pretty much from here down are templates that I've made for ASU or for MCC as various examples. So going to a sidebar view, this one's a little more formal. What has the basic conditions of the plus or minus tolerances are defaults. So in inches, and I don't think, oh yeah, right there on top, unless otherwise specified. All right, so we set the hierarchy, we set the criteria that says if I just put a number on a feature, then these are the dimensions that you'll follow. So 2 place decimal was plus or minus 15, 3 was 5 thousandths, and 4 decimal places was 1,000. Those are still pretty wide open tolerances designed to reduce the cost but still hold fairly decent manufacturable parts. And then, of course, it has the first angle. Or, I'm sorry, I said first angle. Third angle, that we're looking at the cone from the end. And should point that out real quick that if we come over, am I going to be able to see it? Let's go down to properties. And under properties, right in the middle of the properties, the type of projection. If you are set to first angle, change it over to third angle. You will not have those weird drawings. So we talked a little bit about that. I'll revisit it just very quickly. My description of first angle and third angle is what is stationary. Right? If the part is stationary and you are moving around the part, that basically becomes first angle. So you're looking at a view that you're calling your front view. As you rotate left, that becomes the view that ends up on the right side because you're now looking from that side. All right, so to most of us, that's going to be backwards. We were taught third angle. So with third angle projection, you're basically holding a part in your hand and you rotate it to the right, you're looking at the right view. You rotate it to the left, you're looking at the left view. You rotate it towards you. All right, I don't know if that's the best description. You're looking at the top. You rotate it away from you, you're looking at the bottom, and you turn it completely around, looking at the back. Similarities, but some fairly drastic differences in what you're going to see on the drawing. First angle isometric views are going to be in the lower left. Our third angle isometric views are in the upper right. All right, so if you see one that's kind of strange, that's probably why. All right, it's a matter of what you get used to. So a couple of things since we're on this page, just in relation to drawings, you can rename the sheet. So if I have a drawing package that I know is going to approach 10 sheets, 20 sheets, somewhere in there, I will change the name to S1 instead of sheet 1, and all of the little tabs going across the screen have a better chance of being able to select those and not overrunning the edge. But most of the time it can stay as a sheet. The scale, this is kind of a hard location to set the scale. And what I mean by that is if I can't find it or recognize it anywhere else, mainly at the bottom we have scales. And these are the global scales for this drawing package, or for this, drawing sheet. Each of the views then individually can be scaled, and well, they should all scale to their parent unless they are a detail, a section, something that is you want to blow up, produce more detail, have better capabilities with. So on the application side of our GD&T, we're going to pick one of these templates. And kind of the nice thing about the sidebar is it gives me this large vertical space, and I have good visualization in that geometry. Not everybody's used to seeing this, and so it comes down to, is it accepted? And let's don't need those. Let's see. All right, the A landscape. So this one's a little more detailed. It has the tolerance default, and then also have a private, proprietary, and confidential. Right. So is it intellectual property? Do you need? And so this is kind of the standard SolidWorks that we'll look at again. But you should, if nothing else, modify it so somebody is in charge of document control, that it doesn't just go out into public domain kind of thing. That there is a way to secure it a little bit. It has, we're into the, it went plus or minus 20 thousandths on this one for the 2 place, the plus or minus 5 thousandths for the 3 place, and plus or minus a thou carried out to 4 places for the 4 place. All right, so again, we're deciding within that, within those tolerances, what it is that we want to be able to control. And then I mentioned the fractional. Are we really running around with tape measures and only able to measure to a 1/16 of an inch? Well, it should still be pretty close to measuring plus or minus 32nd. But do I go get a scale? Do I go get a rule? And move away from the tape measure side of it. So within the industry, we're going to have commonly accepted. These should be things that jump out at you. And then also making the angular, the machined surfaces or profile surfaces a plus or minus 1. Sometimes those are plus or minus a half degree. We only want 1 degree of variation. Problem is it a part that has an angle that is 1 inch long, 1 foot long, or 10 feet long? because that 1 degree angle at 10 feet is going to be a lot more pronounced, a lot more noticeable. And so at that point, we're going to have to override and put a critical eye on what those angles are. Sheet metal bends, those are really at the mercy of the machine and the operator person doing the bending. And so plus or minus 3 degrees is pretty generous to be able to get into sheet metal. So one of my favorite oxymorons is precision sheet metal, which is harder to say than I thought. Really we're putting those open tolerances, leaving it to be able to move, because we want it to be a fairly quick. We want it to be a process that we can use maybe the not most precise, or the least precise tools, our turret punch, our notchers, our rollers, our benders, our finger brake, or the press brake, and not have to hit those numbers every time, but get good consistent bends if we're building boxes, making the corners and the hems and all those other fun things, to where it can be welded. And then once you start injecting heat and weld, it's going to move even further. We know that that process is going to have a downstream effect, and something that we need to consider. So the drawn by and maybe the modeled by for the document, size and rev, and then if we have drawing numbers, I like to include the weight. So if you look at the weight and it's in grams or pounds and it says, oh, this is 10 grams, it's like, wow, that part looks really big on the page, but it's only 10 grams. And then you really focus in on the dimensions. Oh yeah, it's only 2 millimeters wide by 20 millimeters long or whatever. So it gives you an idea of scale and puts you into that mindset. And then the scale of the drawing, the sheets, and then of course got to have our logo in the background. All right, so building templates is something that I mentioned in the videos, and if you want to build a template as a process, there are a couple of videos that it starts with the part, and you're deciding what data you want to track with the part. So what are the just like this, who drew it, what's the finish, what's the material, those initial things that we talked about in the scope of work and the specifications. How do we present that on the drawing in the best way to communicate that need, want, and have to have. All right, one more to look at is going even further. All right, so I like the format. Way back when I started board drafting, we had the 3/4 or an inch across the bottom. And so this one didn't really fully develop. I would probably go back and reduce the size of my logo, make sure to put in the tolerances, and the thing that we were missing was the icon that told us if it was first angle or third angle on the last one. Would put in the icon, and that's something that we could make into a block and be able to manipulate as the group. All right, so that's something that is running in the background of SolidWorks. But this gives a lot of horizontal space rather than what we'll see with the standard drawing templates, where kind of one corner and almost a useless corner, take up about 1/3 of my sheet, or it feels like about 1/3 of my sheet. So being able to manage a B size. Do we have the capability of printing out C size, D size, or custom sizes? Then we need to consider those templates as well. All right, so on the drafting side, whatever drafting class, whether it was a board drafting, AutoCAD, SolidWorks is the first time you're starting to see the templates, then when I go into the default for SolidWorks, it's going to ask me which of these sheet formats would you like. And so we have the ANSI A size, landscape, portrait, and then everything else is pretty much landscape all the way up to an E size. If you're not familiar with how these work, then basically the A size is our 8.5 by 11 sheet of standard paper. When you unfold it, all right, along the long side, so it becomes 11 by 17, then that's a B size. When you unfold it again, there are actually two ways that you can go, if I'm remembering this correctly, that you end up with a C size that works out to, what, 22 by 34, or let's see, which way can that go? Maybe that's not the one. Anyway, 22 by 34, depending on maybe if it's mechanical or architecture. Now I'm digging into the Wayback Machine of things I don't do every day. All right, and then we're unfolding it again to get to a D size, unfolding it one more time to get to an E size, or folding it itself. So the thing to watch out for is I have a lot of people that if it is only shows standard formats for, and ISO is your default format, then A0 is the largest and A4 is the smallest. So A4 represents our 8.5 by 11 sheet. And not sure how I got that one to portrait. And then they keep getting progressively bigger and bigger. So we want to build those in. We're going to uncheck. And then at the very bottom, now those are some of the different, oh wow, pulled in all of them. So since I haven't pointed this in my my options to where I keep my document templates up here under the new, it doesn't appear to be showing me. So that may be a problem if we add another sheet. Okay, I'll have to address that a little later. All right, but for our purposes, the A landscape will satisfy the drawings. If you create a template and want to use a custom template, that's fine. So as I was saying, is that my drawing template kind of comes across the bottom here, and we gain this upper space. All right, that's a preference. And if I need to track the drawn, the check, the full engineering process, if we have those levels of checks in the company, then we can build in, and those people have to approve the drawing. It gets reviewed, it goes to the next level, and then at the end of the day, it's released for production. All right, if our process is at that level of complexity, then we want to make sure that each of those are taken care of. And then, of course, the dimensions. We don't have the first angle or third angle, has the proprietary confidential. And I haven't really seen anybody use the next assembly and used on as a continuation of, this is a part and we're tracking where the parts are in the, kind of our hierarchy. So let's just say I haven't seen this used effectively. And then we get into the size, the revs, titles, and more information as you go. So at this point, if you were to go in and create the drawing, that's going to be the part that we're going to work on. That's what's going to satisfy the assignment for tonight. Okay, so the build-up. We're going to detail a block with kind of like what we did last time, without the planes, without the surfaces to illustrate those flatness tolerances or the parallel tolerances that we were referring to. So basically, we'll make a 3-view drawing. We'll do a mix of the plus minus dimensions and the GD&T. So if you happen to have saved that one, you can open up and use it. If you did not, then we're going to create a new part. And I did my part inch, but you can now let me go back and make sure that I have something that's at least reasonably looking like yours. So you're going to pick the part and open that up, and we'll open up a sketch in the front plane, and we're going to make a 1, 2, 3 block. So does everybody know what a 1, 2, 3 block is? Part of our setup, part of our, it can be part of the inspection. And so basically a block that is 1 inch by 2 inch by 3 inches. And pick your favorite side. All right, so picking on an object, right? I know my fingers got ahead of me there, so went into rectangle. Make sure the rectangle is placed at the lower left, and we're going to drag out some distance. When you go into the smart dimension, then we're going to pick on the object, and we have 1 inches. I'm going to make it by 3 inches, and then I'm going to extrude it, coming over to the features, extrude it out 2 inches. And I don't really care if it comes towards me or away from me. We can reverse that later. All right, and then Control 7 to get to the isometric. All right, so we'll have some time in lab to revisit this. So if run into questions, and then also the video we'll post to help you get the drawing made. All right, so I'm going to save this, and let's see if I created a folder. Oh, my vice drawings came up. All right, we're going to see those here in a little bit. And I created a folder last time for the spring 2019 semester, if you have that. Otherwise, save it in documents somewhere you can get back to it. And then I'm going to do just 1, 2, 3. All right. So once that's created, now we have an object. We have an object with features. So one surface, and the conditions that we would want to pick for those setting up for the form and for the datums is what's going to be the most accessible, what's going to be the visible items out of this group. So to start off with, everybody can kind of approach the drawing or work within the template. Where this gets a little more involved is when we go over to model-based definition, Dem Expert, and then taking it a step further, and as we build up into assemblies, going into tolerance analysis. So those tools are, I would consider, a little bit higher end. We need to make sure that we cover, again, those basics. And what I'm fond of saying is, when you can say it with me, and we've said that for the last 2 dozen times, then I've said it enough. Right? It's one of those, the repetition, hearing the definitions or seeing the application over and over, that's what's going to build it in and cement it into your memory. All right, so we have the two files. So if I were to go up to Window, I can leave the part open, and I'm going to switch over into the drawing. The drawing was set to either read off the view palette, or we can come over to the view layout and do model view. At this point, I'm going to have you do the view palette. All right, so with view palette, on the right side is the task pane, and I'll close that and go back into it. Is on the very right side, fourth icon down, will say view palette. When you expand that out, we're going to pick the part that is open. All right, so at the upper left, and then it's going to show us all of those available views. So the front, the top, the right, the back, left, bottom, isometric, dimetric, trimetric, and whatever the last current view was. All right, so based on my selection, if I made the front view, right, from the standpoint of applying these tolerances, applying the feature control frames, at this very basic prismatic shape, I'm just going to drag and drop the front view in. Okay, and it's a little bit large for this sheet. And I don't know that I'm going to need all 3 views, but I'm going to go ahead and put all 3 views in. So when I drag out, I'm in a projected view. And the projected view is going to be tied to its parent, which is the front. And then if you want to go isometric, you can put in the isometric view. All right, and then just grabbing any of the view windows, you can move around, start to navigate the locations on the drawing sheet, and get a feel for spacing. So the thing to notice is the top view only moves up and down; it doesn't move left to right. The right view only moves left and right, not up and down, because they're tied to, by alignment, to the front view. When we move the front view, then the top and the right move with it. All right, and the isometric is, well, semi-independent. All right, so As far as scale, in the bottom right on the status bar, we have the 1:1 if you click. If we went to half scale, then that looks a little bit small. I don't know if the dimensions are going to overrun it. So somewhere in between, I think would probably be good. So if we come back and go into the sheet properties, that's going to take us into that pop-up again, where we set the sheet format, where we could rename the sheet, and I can go to something like 3/4, and then apply the changes, and that looks pretty good for the size. All right, so we're going to try and stay in that kind of nominal fractional half, 1:1, 2:1, 1/2, 1/4, 1/3. You know, not getting too far out with 13/16 and 37/64. Not even close to a reasonable scale. So, you know, probably go out keeping it in quarters or thirds and try to manage it that way. All right. So once we have this this part in place, now we can actually do tolerances. So my general process, and we'll go through this again, is if we are working in an assembly, and really, you know, like I started off with, if it's just a block sitting on the table and it doesn't have to connect to anything, it doesn't require any fasteners, we're not even going to glue it to anything, then you know, it can pretty much go without tolerances, unless it serves some specific function as a fixture or some portion of our tooling. All right, so once we get into the stack ups, I would go add sheets, add the next part, get all of my parts into position, start getting that overview of how these pieces assemble and go together, so that I can start thinking about what are the critical tolerances that I want to drive with GD&T. All right, so if we go into annotation and into smart dimension, then I can place a 1-inch dimension, and keep in mind that this is the ISO. If you are in ISO and you want to be in ANSI, we will we'll change that over here in a second. So if I don't put a dimension on a particular view, then I really don't need that view. So I can get away with the width at 2 inches and the length at 3 inches. And for all practical purposes, I can open up that space for the right view by just highlighting the view and hitting delete. Okay. So this driving the standard tolerances, you know, plus or minus. Oh, well, this is the default, so there's a bunch of zeros in there. All right, so we probably would want to modify those in our normal sheet. So, right. So if this satisfies the criteria, I don't really need to take it any further. Right. The plus or minus 5 that we would build into that table, that's going to, you know, satisfy our conditions. Now, the flatness, the parallel establishing datums and going further into it, we're saying we don't need to control that, and so we're not going to come back on an inspection and all of a sudden start talking about flatness when the part is 1 inch plus or minus 5. Whatever you know, whatever angles or geometry is being produced, we're going to live within that, because this is our legal document. This is our production document, what we want made. All right, so said we would come down and put in a 3 decimal place at plus or minus 5 thousandths. I'm not going to have you modify templates at this level. We'll do that in the SolidWorks class, and then if you want to use those, you have access to templates that you've created. So the assumption here is that 2 decimal places will be plus or minus 10, and 3 decimal places will be plus or minus 5 thousandths. All right. So no datum feature is established. So we do want a geometric tolerance, and the choices are we can place it in relation to a surface. So this top surface is our biggest area. When we set it down on the surface plate, we set it down on the pieces, it's going to provide us with the greatest stability. Right? If I set the this edge as flatness and this side is parallel, I'm losing some of that stability. I'm not going to be able to have the same types of measurement. So I want to, look at it from the standpoint of from the manufacturing side. What is probably the first geometries that I'm going to machine? But again, maybe that was the point I was going to make with the GD&T handbook was the drawing does not drive the manufacturing process. It does not suggest. It does not even say you have to do it this way. Right? Whatever shop you send out to quote, whatever shop you have within your company, they're going to look at that and say, this is the equipment that I have that will hold those tolerances. This is how we're going to make it. All right? You can have input on that, but the drawing does not drive. All right? The machinist, the manufacturing group, they drive. All right? So we're setting controls that we want a desired outcome, but they determine how to get to that end. All right? So I can attach my flatness to the surface. We can make it an extension line. I can point it, probably not as visible, pointing it to this top surface as it would be to attach it to the line. We'll place it, and then I want the flatness call out, and I did that before. I'm a pre-selector, so I'm going to have to break that habit with the GD&T. We can always go back and modify that one. So 0.005. Oh, sorry. Probably a flatness of 2. We're not taking it out to 4 decimal places, so the rounding is kind of down. But our general rule would be that we can't really have a plus or minus 5, and then a flatness that says you have plus or minus 5 as well. All right. So if we have let's see, tolerance of, oh, no, I did that math wrong. Yeah, I just did that math wrong. All right, we'll try that again. Plus or minus 5, I could not have a flatness of 10 thousandths. I would be at the limits already of the dimensional tolerance. And so we want to be under that by at least half. So plus or minus 5, we could do 5, but if we were to take it to probably 2 thousandths, that may be a little more control than we need. All right, and then I'll hit OK. And since I applied that one, but not really what I wanted it to do, I will reapply it. And then this would be where we would start to call out parallelism. So make sure I'm getting my terminology correct here, because the flatness and the tolerance on the 1 inch, my tolerance zone at its max would be 1 inch and 10 thousandths. All right, at 2 decimal places, which I just caught that I didn't change, the plus or minus 5 on the top and the bottom now adds up to the same tolerance zone that I have on the dimension. Does that make sense? Getting blank stares on that one. So, all right, so we're going to explore that one a little bit more. So position, I can point to it with the arrow, or when I pull down, it's going to drag off the side. That's probably the more common. This one, I'm going to double click, which will let me back into editing. And we're going to set it as parallel. And if I make it parallel to 2 thousandths, then that will stay within the tolerance zone. Let's see, so is that going to come out normal? That one came out flat. There we go. All right. So when we look at these tolerances, all right, so the flatness at this lower level, if it grows to and this were to grow to, it's still within the capability of the tolerance to hold the plus or minus 5. Maybe that's a better way to say it. All right, we're gonna have to do stack-ups. All right, so right now we're just going to place a couple of tolerances, get a feel for how this works, and then I want to look at the conditions that would be able to generate those items. So I would like you to produce this basic drawing. Let's see, if you go into the notes, let's see, run an annotation, the little A with the note, then at least under the title we won't drive any further. Go ahead and put your name as a note somewhere on the print. Save it, and when you turn this in, all right. So the canvas for the SolidWorks, I have you create zip files, and we may move into that. This is only going to be two files. So when I create the assignment 1, then we're going to start to build those out, and we'll create the zip file so that we can include more files. If I don't have the part, then when it opens up the drawing, I get 3 empty views, 3 empty squares, and I don't get any of the dimensions. All right, so I need the part file, and I need the drawing file. All right, for both of those to work. All right, so taking this further, and again, I'm trying to take a lot of small incremental steps, knowing that the SolidWorks isn't necessarily everybody's first language. So we'll get into more and better complexity as we go. But the next steps would be to decide how we're going to apply a datum. That's what I missed. Okay, I'm sorry, I'm getting tired. Is the flatness is our base. It does not get the datum. At this point, I needed a datum call out to do the parallel. So that's where we go back over and say that our flatness gets the a datum and attached to the extension line or to the surface. All right, and then the parallel is in reference to the flatness, and I can go back in and edit it. And we're not doing conditions to the tolerance, to the frames. Let's see, is it going to let me pick? Oh, I needed to put in the A and accept and OK. Okay, so in reference to the 2000s flatness, now I have parallelism of 2000s as well. All right, so I'm going to pause it there, and we'll go into the manufacturing portion of this. All right, so the part name carries over to the drawing. Those can stay aligned as 1, 2, 3 and 1, 2, 3. So if I hit save, it's going to default, and it takes me back to the same folder. Also, if you're on the class computers, make sure you email this to yourself, put it on your flash drive, go ahead and upload it to Canvas, and then we'll have it when the computers cycle and reset. So once I save that, now my screen is a little bit, but on your screens you should see that there is no asterisk. As long as there's an asterisk next to the title up top, it needs to be saved. You're somewhere in the process and can save that back. All right.